Welcome to video 1 for the computer programming unit. In this one, I want you to be able to program a robot to move through a maze. I want you to write a program using the potentiometers. I want you to write a program using touch sensors. And I want you to write a program using the ultrasonic sensor. So to get us started, let's review. First off, we have our microcontroller. It is the VEX Cortex. On the Cortex, on the left side here is where we have our motor ports. On the other side, we have our analog and digital. So for sensors, an analog is something that sweeps through a certain value. So things like the ultrasonic rangefinder, potentiometers, things like that would be plugged into the analog. Digital is either on or off. So a switch would be plugged into the digital. So like the bumper switches or the limit switches, things like that. On the front, we have our on-off switch where we plug in our main battery, and we don't want to forget our backup battery holder. So looking at the microcontroller itself, we have that Cortex M3 processor. Remember that the processor is responsible for translating programming and instructions, processing the commands, executing the proper responses. It also features an array of ports for interfaces. So of those ports, we have 10 motor ports, 8 of which are 3-wire, and 2 of which are 2-wire. The 2-wire are on ports 1 and 10. 2 through 9 will be the 3-wire. We got the 1I2C smart sensor port. We won't be using that. The UART serial ports, we won't worry about those. We don't have any LCD screens. But the 8 analog ports and the 12 digital ports are the ones that we would be using. And then obviously we have our battery ports. So for programming, we need to think in terms of behaviors. And a behavior is anything that the robot does, such as maybe turning on a single motor, moving forward, following a line. Things like that are all behaviors. We're going to be concerned with 3 types of behaviors: basic, simple, and complex. So taking a look at this code, first off, we see this line right here, B motor reflected port 2. All that does is it flips the polarity of the motor attached to port 2. You could do the same exact thing by just putting a negative in front of the 127 or whatever. But this would be a quick way to flip one of the motors so that you don't have to worry about putting that negative. Alright, so taking a look at the code, this should look familiar. This is the same code we used last year. A basic behavior we see, we've got motor plugged into port 3 equals 63, so that's a very basic behavior. It just turns on the left motor at half power. Then the simple behavior is turning on motors ports 3 and 2 half power for 2 seconds. So that's just telling the robot to move forward. So that's an example of a simple behavior. And then a complex is the entire code. So we see that the motor is going to move forward, make a turn, and then move forward again. So that would be a complex behavior. So to get that into writing, basic behaviors, that's, everything in the program must be broken down into tiny behaviors so that the robot would understand. So an example of this would be a single statement or a single line of code. The simple, these are going to be simple yet significant tasks, and basically you can think of it as you know something that we're going to do, like moving forward for 2 seconds. Almost forgot about my example. Going back to the previous one. So an example of a basic behavior is just simply turning on a motor. All right, now, simple behavior. So again, an example of a simple behavior. Move the robot forward. Finally, we come to the complex. It's the big picture. What does your robot need to accomplish? So an example of this would be like following a path through a maze. So then, looking at this again, we can make a flow chart of everything we need to do by starting with a large behavior and then breaking it down into smaller and smaller pieces. So, for example, to follow a path, we need to go forward for 3 seconds, make a 90-degree turn, go forward for 5 seconds. Well, we can take each of those tasks and then figure out what we need to do to accomplish those. And once we have that in place, we can then start looking at the actual code needed to accomplish each of those individual basic behaviors. Well, that concludes video 1.